All right, we're in 3-5. In fact, we're going to start just ahead of 3-5 in the book. This is page 169, and what we're getting into today is dealing with these things called matrices, or we're going to deal with matrix operations. And so on page 169, you're introduced to what a matrix is, and where it's going to go is it's going to end up helping us solve systems of equations. It's kind of the end game here. But we're going to kind of look at some of this stuff, and here it goes. All right, so here's a matrix. This is what a matrix looks like. This is matrix A. Right here at the top of 169. Each spot in a matrix, each different number is called an element, all right? So if we say the element of a matrix or the elements of a matrix, we're talking about the data that goes inside of those. The main thing about how to set up matrices or how to do matrix operations, we've got to know the dimensions of the matrix. And so it is always written in the number of rows by the number of columns. So matrix A right here is what they call a 3x4 matrix. There are 3 rows. Rows go left to right, and there are 4 columns. Columns go up and down. And so, think of a column like holding up a house. Again, columns are up and down, rows are left and right, and you do it. The number of rows by the number of columns is how you make up or how you name matrices. So this is a 3x4 matrix, 3 rows by 4 columns. That's going to be important to know as we start doing some math with those. So we can keep flipping. As we get into 3-5, I'm going to go ahead and jump to the top of page 172. This is a great table for you to have down. This walks you through what happens if you're adding matrices or subtracting matrices. So what has to happen for this to work, your matrices have to have the same dimensions, okay? Matrix A right here is a 2x2. Matrix B is a 2x2, 2 rows by 2 columns, and then it shows you how the math works. So what's kind of happening here, and I'll walk you through it. If I'm going to add up matrix A and matrix B, and these are the 2 matrices, my top left element of my answer is going to be the top left part of matrix A plus the top left part of matrix B, and that gives me that value. Now I'm going to show you this with numbers because I think it's pretty easy to see, but if you like having hard and fast rules, this table right here is something that I would recommend getting into your notes. Look at this example right here. They go add up 2 2x2 matrices, and you can see this top left corner is 3 plus 2. That's the top left of each of the 2 matrices we're adding up. The top right is -5 plus 0, the top right element. So it's top right plus top right, and you put the answer in the top right. Look at this, bottom left, 1 plus -9, and it goes in the bottom left element of our answer. Okay, and then bottom right, 7 plus 10 goes in the bottom right. And then I'll show you how the answer works, but that's basically how we're setting this thing up. Okay, all right, so here's absolutely what's happening right here. So they give us an example 2. They give us 3 different matrices, and they say, all right, matrix A is 16, 2, -9, 8. They give us that matrix B. By the way, matrices will be written as capital letters. That's a little bit different than seeing just, lowercase letters. So that's kind of looking into matrix operations. Matrix B is -4, -1, -3, -7. And matrix C, notice it's different, 8 and 6 make up those elements. So A and B are 2x2 matrices. I'll write that here. That's a 2x2. That's a 2x2. Matrix C is 2 rows, but only 1 column. So that's a 2x1 matrix. All right, and then they just kind of walk you through wanting to set some of this stuff up. All right, so this is example 1, and this is part A right here. All right, and it says, hey, and it gives you capital A plus capital B. That means add matrix A and matrix B together. All right, so again, matrix A, 16, 2, -9, 8, plus matrix B, -4, -1, -3, -7. Again, maybe double check and make sure you wrote them down right, because if you write them down wrong, then you're probably going to do the wrong math. So what you kind of saw, what I was pointing out earlier, is if I'm going to have an answer matrix or a solution matrix, okay, it's going to be 2x2. So there's basically 4 spots that we're going to fill up. Again, this is a 2x2 matrix. This is a 2x2 matrix. They have to add up. They have to be the same, and they're going to add up to be the same size. So here's how we do it. So if I'm going to find this top left spot right here, then I'm going to go add the top left plus the top left. So this turns into 16 plus -4, which is 12, and that goes in the top left. Now I'm going to do top right plus top right equals top right. Again, the reason we're adding these is that's what it said to do. So 2 plus -1 is 1, and that goes in the top right. Now we do bottom left plus bottom left. -9 plus -3 is -12. And then we do bottom right plus bottom right. 8 plus -7 is 1. This is the answer when you add matrix A and matrix B in this situation. Okay? Again, we started, or both of our matrices we were adding were 2 by 2, so we add them up and we get a 2 by 2 matrix. All right, part B right here. It says, hey, take matrix B and subtract matrix C. All right, so matrix B, -4, -1, -3, -7. And I'm going to subtract matrix C. We have an issue. This is a 2 by 2 matrix. This is a 2 by 1. Their dimensions don't match. I cannot subtract these. We would put no solution. It doesn't work. They're not the same size. In matrix addition or subtraction, the matrices have to be the same size. Now, I'm telling you that's going to change when we do matrix multiplication. All right, another thing about matrices that's vitally important is that you keep them in the right order. So this says do matrix B minus matrix A. Make sure you list matrix B first and matrix A second. Matrix B is -4, -1, -3, -7, minus matrix A is 16, 2, -9, 8. All right? So these are both 2 by 2, so we're good. Now pay attention to the minus sign. So here's what happens in each spot. I'm going to do top left minus top left. So that's -4 minus 16 is -20. If you're not good at that math, if you don't like doing the negatives, let the calculator do it. All right, let's do top right, -1 minus top right. So that's -1 minus 2 is -3. All right, let's do bottom left minus bottom left. Now notice that's -3 minus -9. This minus and negative turn that 9 into a +9. So I really have -3 plus 9, which is 6. Be careful with that. And then I have -7 minus 8 is my bottom right elements. And I'll put it in the bottom right, and I get -15. And there is matrix B minus matrix A in this setup. All right? So that's kind of how it, pretty much how it works. Now, when you get down into the guided practice, you can do 2A. They're the same size. You can do 2B. Those are both 2 by 3 matrices, but you can't do 2C. That's 3 rows by 2 columns and 2 rows by 4. A 3 by 2 and a 4 by, a 2 by 4 don't match. So we can't add those up. Good. All right, let's keep going. So now we're going to do this thing called scalar multiplication. All a scalar is a coefficient for a matrix. So here's what a scalar, here's kind of the rules. If you like having a set, like a step-by-step deal, there's the rules. We're just going to go into it. I'm going to example 3. Okay? And it says this. It says that we have matrix R, and matrix R is this, -12, 8, 6, -16, 4, 19. And they want us to find 5R. Well, what does that mean? That means my scalar is 5. Scalar's like a coefficient for a matrix. What that literally means is I'm going to multiply 5 by every element, in this instance, in matrix R. So it's real simple. It doesn't matter the size of the matrix at all. We're just going to kind of go distribute. So what happened up here when they're teaching you scalar, they put a scalar of -3 in, and they multiplied each spot by -3. Well, that's what we're going to do with 5 right here. So I'm going to go 5 times -12 is -60. 5 times 8 is 40. 5 times 6 is 30. Notice I'm keeping the elements the same. That's top left, top middle, top right. Top left, top middle, top right. After we multiplied by 5. Do the bottom. So bottom left, I'm going to do 5 times my bottom left. 5 times -16, -80. 5 times bottom middle is 20. And then 5 times bottom right, 95. 5 times 19 is 95. This is the answer when you multiply a scalar, all right? In this instance, that scalar being 5. Notice in guided practice 3, the scalar is -4. You would take -4 times all of these elements. That's a 2 by 4 matrix. You end up with a 2 by 4 matrix. All right, kind of flying through that so I can show you the whole, kind of all of it in one example. Going to example 4. All right, so they give us this. They say matrix A is -9, 12, 2, -6. And they're just naming what these matrices are. Doesn't always have to be the same. Matrix B is -4, -8, 2, -3. Now notice what they say. They say do, -4B minus 3A. So what we're going to do first, all right, is we are going to take -4 and we're going to multiply it by matrix B, which is -4, -8, 2, -3. And I'm going to take -3 and I'm going to multiply that by matrix A, -9, 12, 2, -6. Okay, so we have two scalars here. Well, let's go multiply those out. Now, they're both 2 by 2 matrices, so we know that we can eventually subtract these. Now, notice what I'm about to do, and I'll kind of hit on it in a second. We're going to go we're going to multiply everything by -3 over here to take care of the signs. Okay, to take care of the signs. All right, if you don't do that, you leave it as a subtraction problem. So I'm going to kind of give you a little shortcut on that. All right, here we go. -4 times -4 is 16. -4 times -8 is 32. -4 times 2 is -8. -4 times -3 is 12. So there's -4 times matrix B. Now I want to show you something here. Go ahead and multiply -3 by matrix A. Notice I didn't put a sign here, okay? I did that on purpose. All right? So here we go. -3 times -9 is 27. -3 times 12 is -36. -3 times 2 is -6. And -3 times -16 is +18. All right? Everybody good with that? I just kind of distributed that -3. That's what a scalar is. Now, since I did that and I multiplied all of that second matrix by -3, I've got to put a plus sign here. Okay? Not to get too confusing, if you wanted to leave it as minus, you would just distribute the 3. I like distributing the whole thing because that's kind of how we do it, and it just changed it into a big addition problem. So now I've got two 2 by 2 matrices, and I'm just adding them together. Top left with top left. All right, 16 plus 27 is 43. Top right plus top right, 32 plus -36 is -4. Right, bottom left plus bottom left, -8 plus -6 is -14. And bottom right plus bottom right, 12 plus 18 is 30. And there is -4 times matrix B minus 3 times matrix A, and we get that. And you're like, man, I don't really know how this plays in. Where this is going to take us is this is going to eventually be very nice for us to use solving systems of equations, especially 3-variable systems, which you just learned not too long ago. All right, so make sure you have all these examples written down. If you miss something, I'm following the problems in the book. You should be able to go back in the book and kind of see, but you're also always welcome to ask for help. Thanks.